Alright, so today we're going over relative motion. So relative motion is just motion relative to another object, whether it be something in motion or something standstill. So let's say we have a car right here going at 15 miles per hour to east, and then we have a person running or jogging at 5 miles per hour due east. From a reference frame of the car, where is the person or which direction is the person moving at? So since the car's already going at 15 miles per hour, from the reference frame of the car, the person is going to be jogging 10 miles per hour due west. And that's, you would just figure that out by 5 minus 15. But for relative motion, you can also use the vector rule, in which, let's say, relative to the car, we're going to have a vector of 15 miles per hour to the left, since the car is moving 15 miles per hour to the right, and then the person walking 5 miles per hour to the right. And using the vector rule, we connect the start of the first to the end of the second vector. We get a final relative vector of 10 miles per hour to the left, or due east. And one thing you can also do is when you have relative motion in 2 dimensions, you do want to know how to use similar triangles or the Pythagorean theorem in order to find relative motion, whether it be like a hypotenuse or something. Alright, so for number 18, we have a boat takes 3 hours to travel 30 kilometers down a river and 5 hours to return. How fast is the river flowing? So we're going to be looking at 3 hours here. So if you remember, average velocity or velocity average is equal to delta distance over delta t. So we're going to find the average velocity that the boat goes there and returns. So for the first one, we're going to have distance, which is going to be 30 kilometers for boat trips. And then time is going to be, we're going to set it in terms of hours. So our average velocity is going to be 10 kilometers per hour. And then for the second trip back, we're going to have distance, delta t again, and then over delta t, which is going to be 5 hours. So on the way back, his average velocity is going to be 6 kilometers per hour. Now let's use the vector rule here. So on the way there, he's traveling east. Let's say he's traveling 10 kilometers per hour east. And on the way back, he's traveling 6 kilometers per hour on average. So these are his average speeds on the way back, and they're over an equal distance. So let's use the vector rule. Let's connect the start of the first vectors to the end of the second. We're going to get a final vector of 4 kilometers per hour to the east. So 4 kilometers per hour to the east is going to be our how fast the river is flowing, or east, given the fact that the boat is traveling east to begin with. So 4 kilometers per hour, that is going to be how fast the river is flowing. Alright, so let's take a look at number 19. So Mary needs to row her boat across a 100 meter wide river. How that is flowing at the east at the speed of 1 meters per second. Mary can row with the speed of 2 meters per second. If Mary points her boat due north, how far from the intended landing spot will it be when she reaches the opposite shore? So this is going to be a depiction of the river. So it's flowing east at 1 meter per second. She's going to be rowing her boat north at 2 meters per second. And then this is going to be 100 meters wide. So first, let's find out the time it takes her to get to the other side just based on our vertical component. And then we'll figure out how far she's drifting off to the east as she swims there. So if you remember, we're going to use average velocity equation again, which is delta d over delta t. So our average velocity is going to be 2 meters per second over the distance, which is going to be 100. And then delta t is what we don't know. So we could switch delta t and 2 meters per second. If we do that, we get delta t is equal to 100 over 2, in which delta t is equal to 50 seconds, and that's going to be the time it takes her to get to the other side. So this is going to be 50 seconds. And now the river flows at 1 meter per second to the right. So all we need to do is just multiply 1 times 50, and that is 50 meters. And that's going to be how far to the east she drifts as she reaches the other shore. So the answer will be 50 meters east. Alright, now let's look at B. So what is her speed with respect to the shore? So this is going to be the shore. So we know that she's going to be traveling north at 2 meters per second. And then the river is going to be sending her 1 meter per second to the right. So we're just going to use the Pythagorean theorem here. So if you remember, c squared equals a squared plus b squared. So we're going to have c squared is equal to 2 squared plus 1 squared, in which c squared is equal to 5, and c is going to be equal to square root of 5. So her speed respect to the shore is going to be square root of 5 meters per second. Alright, so let's take a look at number 20. So when the moving sidewalk at the airport is broken, as it often seems to be, it takes you 50 seconds to walk from your gate to the baggage claim. When it is working, you stand on the moving sidewalk the entire way. Without walking, it takes 75 seconds to travel the same distance. How long will it take you to travel from the gate to the baggage claim if you walk while riding on the moving sidewalk? So we're given two figures here, 50 seconds and 75 seconds, and they're both the same distance. So the moving sidewalk is going to be essentially what makes you walk faster at airports. There's really no other way to explain that. But so since we're given that both are the same distance, both time frames, let's give it a distance. Let's give it a numerical value to help us with this question. So let's say the moving sidewalk is going to be equal to 25 meters. So all we need to do now is find the average velocities and add them together. So we're going to use the average velocity equation, which is going to be delta D, which is going to be 25 meters, over the first time frame, which is 50 seconds. So 50 seconds. And then let's do the second time frame. So velocity average is equal to 25 meters again over 75 seconds, which is the second time frame. And let's figure out the numerical values for these. So this is going to be 1/2 meters per second, and then this is going to be 1/3 meters per second. So when you're walking that distance, you're going to be walking at a speed of 1/2 meter per second, and the moving sidewalk will move you at a speed of 1/3 meters per second. To find how long it'll take us to travel if we walk on the moving sidewalk, all we need to do is add them together. So it's going to be 1/2 plus 1/3 meters per second, in which we could just make them have the same common denominator. So we can multiply 1/2 by 3, which is going to be 3 over 6, and multiply 1/3 by 2, which is going to be 2 over 6, in which we're going to have an answer of 5 over 6 meters per second. And that is going to be our velocity when we add together the walking speed and the speed that the moving sidewalk moves at. But now that we know the velocity added together and the distance of the moving sidewalk, let's find the average velocity when you put them together. So velocity average is going to be, or rather, we already have the average velocity. 5 over 6 is going to be equal to delta D, which is going to be 25 meters, and delta T, which we don't know. We could cross multiply, so we're going to have 5 delta T is equal to 150, and we could divide by 5. So we're going to be left with delta T is equal to about 30 seconds. Or rather, exactly 30 seconds, and that'll be your answer. Alright, so let's take a look at number 21. So a kayaker needs to paddle across a 100-meter wide harbor. The tide is going out, creating a tidal current that flows 2 meters per second east. The kayaker can paddle with a speed of 3 meters per second, and then we have questions A and B. So feel free to pause the video and try this question out. Alright, so let's take a look at A. So in which direction should the paddle, or he should paddle in order to drive straight across the harbor? So given that the tide is flowing at 2 meters per second east, in order to negate that, we want to be flowing at 2 meters per second west as our horizontal component. So we know that we have to paddle somewhere in the vicinity of this area. Our first vector, this 2 meters per second west, is a must. We must paddle at that speed in order to negate the fact that the river is flowing at 2 meters per second east. And 3 meters per second is going to be our speed. That's maximum speed we can do. And now this vector is going to be our vertical component, or y component rather. This is what we don't know. For now, for A, we don't really need to know that. So this is going to be theta. We want to find out in which direction he can paddle in order to strive, or in order to travel straight across the harbor. So we know the adjacent and the tan values. What trig value works with adjacent and tan? Now, if you remember, it's cosine. So cosine is going to be equal to adjacent over tangent. In this case, cosine theta is going to be equal to 2 over 3. In this case, you want to put down cosine -1, 2 over 3 into your calculator, and that's going to give us theta. So if you do that in your calculator, you're going to get that theta is equal to 48 degrees, or 48.2 degrees, but we're going to round to 48 degrees. So that's going to be our answer for A. So for A, in order to travel straight across the harbor, he's going to have to travel at 48 degrees above the negative x-axis. And I'm saying negative because he's also flowing with the x component of -2 meters per second because he's moving to the west, or he's paddling to the west, although he's not moving to the west. But that's because of the current flow. Now let's take a look at B. So how long will it take him to cross? Now we need to find the y component of this. The y component is going to give us how fast he's moving in the y direction. So in order to do that, let's use a Pythagorean theorem. So we know c squared is equal to a squared plus b squared. And let's say 2 meters per second is a, 3 meters per second is going to be hypotenuse, which is c. So we have 3 squared is equal to 2 squared plus b squared. And that's going to be 9 is equal to 4 plus b squared, which is also going to be 5 is equal to b squared. So b is going to be equal to square root of 5. So square root of 5 meters per second is going to be how fast he's moving in the y direction. Now we want to see how fast it's going to take him to travel 100 meters if he moves at square root of 5 meters per second. So essentially, we could just use the velocity average equation again, delta d over delta t. So we're going to have square root, or rather, let's delete some of this stuff so that we can do it right here. So we're going to have square root of 5 is equal to delta d, which is going to be 100 meters, the distance that he has to cover, and delta t is what we're trying to find. So we could switch delta t and square root of 5. So we're going to have delta t is equal to 100 over square root of 5, in which delta t is going to be equal to 44.7 seconds. And that is going to be how long it will take him to cross the river. Alright, so let's take a look at number 22. So Suzanne is driving north at 60 miles per hour. Trent is driving east at 45 miles per hour and are approaching an intersection. What is Trent's speed relative to Susan's reference frame? So feel free to pause the video and try this out. Alright, so let's take a look at the question now. So let's draw some vectors here. So Suzanne and they're approaching an intersection. Let's say intersection is right here with, whatever is going on there. So Suzanne is driving 60 miles per hour north, and then Trent is driving 45 miles per hour east. as they're approaching the intersection. So in terms of Suzanne's reference frame, this is going to be how fast Trent is speeding or moving in terms of Suzanne's reference frame. Suzanne is going to be right here. So it's going to be this length right here that's going to be telling us Trent's speed relative to Suzanne's frame. So if you remember this, if you could see, this looks kind of like a triangle, or it is a triangle. So essentially, we could just find the hypotenuse of this. So, c squared is equal to a squared plus b squared. So c squared is going to be equal to 60 squared plus 45 squared. So c squared is going to be equal to 3,600 plus 2,025, in which c squared is going to be equal to 5,625. And then you would square root it, in which your final answer would be c is equal to 75 miles per hour. And that is going to be Trent's speed relative to Susan's reference frame.